A21. Today we are going to see about that microprocessor, which is Intel 8085 as well as Intel 8086. See, this is the pin configuration of 8086. It will have a 40 pins. 0th pin is ground, and it will have AD pins starts from AD0 to AD14, which is starts from 16, 15, 14, 13, 12 up to 2. And this is the INTR, and this is clock pulse. Again, it is a ground pin. Then this 21st pin is a reset pin, and it is ready pin. And then this is test. This OSO and OS2. Likewise, we have these 40 pins. The 40th pin is VCC. We have to give the supply. The 8086 is a 16-bit microprocessor chip designed by Intel, which gave rise to the x86 architecture. Development work on the 8086 design started in the spring of 1976, and the chip was introduced to the market in the summer of 1978. The Intel 8088 released in the year of 1979 was a slightly modified chip with an external 8-bit data bus, allowing the use of cheaper and fewer supporting logic chips is notable as the process used in original IBM PC. And we're going for 8085. This 8085, the Intel 8-bit microprocessor introduced in that Intel in 1977. It was a binary compatible with the more famous Intel 8080, but required less supporting hardware, thus allowing simpler and less expensive microcomputer systems to be built. An Intel 8085 processor, the produced from 1977 to 1990s, and the common manufacturers are Intel and others. Its CPU clock rate is 3.5 and 6 MHz. The instruction set of this 8085 pre-8x86 and package is 40 pin DIP. The pin configuration of this 8085 are, see here, it has also 40th pin. From that 12th pin to 19th pin, you have a AD pin. What is that AD pin? AD is nothing but A means address, D means data. So here we can have both address and data. Here we will send both A and D here, whereas here in that 28 to 21 we will have A0 to A8 to A15. Here we will send only A. Here we can send A or D. Both we can send here. Here we will send only A. Likewise, this 31st pin is read pin, and this 30th pin is write pin, and this one is SO pin. 37 is clock out pins. Then 36 is reset pin. If you want to have a reset of whole diagram or whole circuit, we will reset here in that 36 pin. And this is the RST pin. This internal or INT or INTA pin is a 10th and 11th pin. Here it is VSS, and 40th pin is VCC pin. From that VCC pin, we will have the supply. Here it is also have a hold pin and HLT and a clock out pin also there in that 8085. See some assembly program we're going to see here in that microprocessor. First of all, the initial stage of this program is whatever we have given in this program, it will first stored in that accumulator. Then only it will move up to some other register where we want to store and where we want to make some operations. Likewise, we will have the program here. You can see here it is move A comma H. A comma 45H. What is that 45? 45 is nothing but it denotes 45H means 45 hexadecimal. The number for this 45 with respect with the hexadecimal value. Thus number will move up to accumulator A. This move A comma 45H means this 45 will move to A from left to right. Here the program will indicates that all of the program we have to take from left to right. It will move like this only. Here also it will move like this only. It will move like this only. This is that normal addition program. So if you are giving that 45H means first we will write move A comma number 45H. So what will happen here? This 45H value is moved to the accumulator. Then the next stage is 86H. 86 hexadecimal value will move up to B. Here add A comma B means in accumulator already there is in 45H hexadecimal value. So add A comma B means this B will add to A. So already in A accumulator there is a 45H and in B 86H. With the addition we will have a 20H. This is the simple addition program for that microprocessor. Then we will have a logical operator program. See here in that logical operator program we will have a OR operations. What is this OR operation? As we know already, OR means if any one of the input is high, the output is high. If both the input is low only, the output is low. But if any one of the input is high means the output is also high. 0 0 0 0 1 1 1 0 1 and 1 1 1. For this we will write this program, our program here. See the syntax of this our program is ORL. First of all we will have the program that ORG OOOH 00H. Then move 07H to A, which means this 07 hexadecimal value will move to the A. A means accumulator. As I said earlier, for this program, for all data will store first in that accumulator. Likewise, we will see in that addition. First, we will store the data in that accumulator. Then we will get some data for B. Then we will add A plus B. Likewise, we will have a data for 07H to the accumulator. Then we will move up to the RO register for this 70H. So 70H will move to R0 register. That is the second line of this program. Then ORL A comma R0 means the OR operation should take care of this A0 A comma RL. So it will have an operation OR operation of these two values. This is the program for OR operation. If it is AND means here we'll have a syntax for ANL, that is the AND operation. Instead of this ORL, we will have a ANL, that is for AND operation. As we know already, what is that AND operations? If the both the input is low means output is low. If any one of the input is high means the output is high. That's for OR operation. The AND operation is if both the input is high only, the output will high. Otherwise, if any one of the input is high, if the both inputs are low, will output will low. That is the AND operation. That operation will takes here with this ORL. Instead of this ORL, we will put the ANL. So we'll have the AND program. Likewise, if we have a XOR program over here means instead of this ORL, we will put XRL. This is the syntax of XOR program. Likewise, we will write the logical operator programs in that assembly language. Thank you.